for the sake of time, people, I introduced the last speaker of this session. We're talking about regulation, DAOs, now a regulation about the crypto economy, but then there is a very important aspect that is also how it affects some other rights, like that of data protection. And it is for me a pleasure to welcome Erbguth, who is a consultant on blockchain and data protection, GDPR. He has, and very important to his background, he has two majors, one in computer science and another in law, and therefore he really takes a very multidisciplinary approach to this new technology. He has been continuously invited to the European Commission, to the German Bundestag, the Parliament of Sachsen, to discuss blockchain data protection and information security. Currently, he lectures at the University of Geneva, the Geneva School of Diplomacy, and the University of Lucerne, and in our summer school. Thank you very much. He's very active in blockchain standardization at the International Telecommunications Union, and he was also a member of the Dean Spec on Privacy by Blockchain Design. Thank you very much, Jörn, for joining this conference.
Thank you very much. Does the mic work?
It doesn't. I think that it is off.
One, two, three. Doesn't work?
It is off, yeah. Yeah, it's always in a different location. It's here. Fantastic.
Okay. Does it work now?
Yeah.
Okay, perfect. Blockchain and GDPR. Thank you for your very nice introduction. The first thing that comes into mind is, well, isn't there a fundamental issue with blockchain and GDPR? GDPR having the right to be forgotten and blockchain having immutability. And of course, this is a tension, but well, let's take a step back. What does immutability mean? And I'm having the same picture as Marco of the law library of the University of Zurich. And to mention that immutability is not new. This achieving immutability through distribution is not new. It was invented by book printing quite some time ago. And it means that you print something, you distribute it to many people, private people, to institutions that worship the books in temples, like this one, and preserves them. And you can manipulate a single copy of a book, but you can't manipulate the book as such because it is distributed worldwide. And this is the basic principle that we have in book printing, and that makes it accepted. Libraries are not responsible for the contents of the books. And at the same time, we are going to lose it. Now we are accessing databases from publishers, and they can censor. Courts are actually asking them to censor the content of publications that they provide online. So we are losing immutability. And before we invested large amounts of money to have immutability, today we are reversing this trend, and we need to balance it. Not every immutability is good, but not every immutability is bad either. But the basic issue remains, what do you do with the right to be forgotten? So GDPR is there, and contrary to Marco, I think the European Union, the European Commission is trying to be ahead of technology with its regulation. When you look what they are currently planning to regulate, and I don't think this will end up good. So I have a rather pessimistic view on it. But well, we now see the effects on GDPR, of GDPR on technology, and it's not always good. And it does not always achieve what it should achieve. But the simplest advice that we already heard some days ago, yesterday or before yesterday, do not store personal data on chain. Good advice. GDPR only applies on personal data. So if you don't store any personal data on chain, you're fine. Well, this is of course a good advice, but not as easy to follow as you might know. Doesn't work.
Perhaps it ran out of battery. Yeah, I
Yep.
will charge it.
So what is considered personal data by the GDPR? Any information relating to an identified or identifiable natural person is considered personal data. In the US, the term personal identifiable information is used, which is a better description of it, but the scope of PII in the US is much smaller, and the scope of personal data in the EU is much broader. Anonymous data is not personal data. Pseudonymous data is mostly personal data. So it's not just about removing names from data to make data anonymous. And the GDPR defines personal data, whether it's possible to identify data information with natural persons, and account should be taken to all means reasonably likely to be used. So not any theoretical possibility to identify renders things personal data. The data protection authorities interpret this a bit different. So you might hear other opinions there, but the European Court of Justice follows this rule. So what are examples of personal data? There is a famous Breyer case where IP addresses are considered personal data. And this is because it is possible to identify a user with the IP address. Why? Because providers are obliged to store this information, and there are legal means to access this information in certain cases to identify the people that use these IP addresses. And when you look at Bitcoin addresses, it's a bit the same, particularly because regulation forced exchanges to store this information, to do KYC. And you can follow the trace. They are clearly identifiable. And then, of course, it depends where you put the threshold, how much effort you can put into the identification. So not every Bitcoin address is personal data, but many are. And when you look at anonymized, like it's called movement profiles or anonymized browsing history, it is also clear that this is personal data if it's large enough, because you can identify somebody by their movement profiles without knowing their name, and identify somebody by their browsing history without knowing their name. When you really do anonymization, when you do aggregation, when you do statistics, etc., you often really end up with anonymous data. So it's important to look at the individual case. Not every IP address is personal data, but many are. So how can you still deal with it? For example, when you want to certify that, like I did in my thesis, certify diplomas, digital diplomas, using a smart contract. So you can take the diploma, you can create a hash value and put the hash value on chain. And there are lots of discussion whether this is personal data or not. In my opinion, it is not if you do it this way, because the hash value does not give you any additional information that you do not have to have in order to arrive at the hash value. However, if you do it differently, if you take the identity, create a hash value, put it on chain, and add some metadata, this person has a diploma, then it is obvious that you use the hash value as a key. And with the key, you obtain additional information, and then it is personal data. So it is very important how you use the hash value. If you use it for key, as a key, then it certainly is personal data on the chain. And this is also true if you do the revocation. So I certified the diploma with a hash value on the chain using a smart contract. And then the diploma has to be revoked. Perhaps somebody found that I copied half of my thesis of an existing publication, and the university decides that to revoke it. Then the university says, well, it is revoked, and through the smart contract, it is connected with the original hash. And whenever somebody verifies the diploma, they see it is revoked. And this is clearly personal information, personal data. No doubt about it. You use the diploma to find out that it has been revoked. So how do you deal with the right to be forgotten? Do I have a right to that everybody forgets the revocation of my diploma? No, I don't. There's a justification for it to be stored, because otherwise I would present my diploma and say I still have my PhD, although it has been revoked. So it depends on the justification. Let's look, is there a justification? When an institution issues a diploma, there is a need to verify this credential. So this is one requirement. And as we said, there is a need to be able to revoke this credential. Why? You cannot hand back a digital credential. You can always retain a copy. So with a paper document, you can give it back, and then you can be sure it's not in the world anymore. But with an electronic document that is signed, for example, with a qualified electronic signature or seal, you cannot do that. And there is another very important requirement. The diploma remains valid when the institution does no longer exist. Of course, the University of Geneva, University of Zurich will very probably continue to exist. But suppose you do a PhD in a very small private university, you don't know, will it still exist in 10 years and 50 years when you still want to use your diploma? And importantly, if it has been revoked, it also, the revocation information also needs to persist. Because if people know that the revocation information is lost, all existing diplomas will lose their trust, because people will not know that they are not have not been revoked before. So this is the requirement, and we need to see how we can achieve it, and there's a justification for it. And this is important. You can process personal data. You can even store it immutable if you have a justification for it. So it depends on the use case. And there, of course, we have to question, is there a right to have only the revocation deleted? And of course, not. But there's a right to have the whole issue of the PhD being deleted. So, for example, there have been cases where people have not just forged a PhD, but they have killed people. There's a case in Germany where somebody has killed 2 people and was convicted for murder. It has been in the press. 20 years later, the person has served his sentence, and the article is still in the press archive, and the person went to court and said, please delete it from the press archive. And the court said, yes, you have the right. Does this be forgotten? So when you look at the diploma, there has been the plagiarism. Of course, you have the right that this is being forgotten, but how can you handle it? And here, the smart contract offers you the very optimized possibility that the revocation will still be visible if somebody still uses your diploma. But if you do not use a diploma, if nobody is presented the diploma, the revocation is not visible to anybody. Of course, the revocation is visible, a revocation entry is visible, but it's not cannot be connected to you. And this is the very advantage of using the smart contract here. And this is why this solution actually is a very optimized data protection friendly solution. Also, it uses immutable blockchain. So you really have to look at the specific use case. Is there a justification for storing the the data immutable? So here the possibility of revocation is well justified. It's optimized, and particularly alternatives are worse. So if you have a list of revoked diplomas publicly available with their numbers or even the names, this would be, of course, worse concerning personal data. And there is also a justification that secure validation of non-revoked diplomas will be possible after the institution ceases to exist. So what are the learnings of this case? That GDPR compliance really depends on the use case. It's no use to say hashes are personal data or not personal data. It depends on the use case. And then still saying, well, you cannot put them on a blockchain, or you can. It really depends how you use them and how you put them on the blockchain, for which purpose and how it is justified. And also, blockchain can optimize the, data protection. So the use of blockchain can actually be very good regarding data protection. It is not always in attention with data protection. But you have to ask, is every bit of information that is stored on chain, or that can be derived through what is stored on chain, is this well justified? There are other GDPR issues that are maybe even sometimes even bigger than the immutability. There's a question of accountability. Who is controller? And there is a question of third country transfer. Going to the question of accountability and controller, the principle of GDPR is is connected to a quite old principle of data processing. So there's some data about you, and there's some institution that controls the data processing that is of data that is connected to you. And then there is the oversight by a data protection authority that is controlling the one controlling your data. And the system that the GDPR uses is a system of controller, processor, and data subject. So the controller is determining the purposes and means of data processing. The processor is processing the data like a computing center, and you are the helpless data subject who is not controlling any processing, who is not doing any processing, who hasn't got a computer, etc. So we see this model is outdated. We all have our smartphones, we all do control part of the processing, but we don't control everything. So this should be the real model. But well, this is the model of the GDPR. And so this model does not only have issues with blockchain, but with many modern models of modern computing. And you can have more than one controller. You can have joint controllers who synchronize, or who know each other, or who act separately. You can have one processor, more processors, no processor. So the controller do the processing themselves, and you have the data subjects. And well, the controllers have obligations and the data subjects have rights. And if the data subjects become controllers, then the whole model of the GDPR is not really working anymore, because then you oblige the data subjects to to the obligations that should protect them, but in that case do not protect them. For example, if on a blockchain you would say that the data subjects are controllers, they have to identify themselves. So they don't have a right to anonymity, but to the contrary. So this is difficult in the notion of in the context of GDPR. And then there is a question, well, who is controller, who is processors? Well, are node operators processors? Are miners, all miners, exchange, etc.? Are the users controllers? And the question is, well, somebody who has not control, can they be called controller, and can they be responsible? And in my opinion, you should really distinguish the different levels. And you should say on the transaction level, the one who signs the transaction is responsible for the transaction, not the blockchain. And on the blockchain level, of course, it depends, do you have a public permissionless blockchain, or do you have a consortium blockchain? A public permissionless blockchain, you don't have anybody responsible because nobody's controlling the system. Nobody can actually control the system, and GDPR means that those who control are responsible. And whereas, so a simple node, they cannot change the system. They can either follow the rules, or they can quit the system. They have no other choice. A bit similar on the smart contract level. On the smart contract level, you can have smart contracts that are deployed and cannot be manipulated by any special private key. Or you can have smart contracts that can be updated, where you have some kind of admin functionality available to special keys. And in case you have this update possibility or this admin functionality available, of course, those who have it have control. If there's no such functionality available, they don't have control. And there is little well, opinion available from data protection authorities. Only the CNIL in 2018 published something very meaningful. The European Data Protection Board said they would publish, they announced it, but they didn't do so far. And when you look at the opinion of the CNIL, they say the user of a public blockchain can be a controller. So the one who is putting a transaction on a blockchain. And if it's for private purposes, they said it could be governed by the household exemption of GDPR. So it does not, it exempts the private users from obligations of GDPR in that case. Somebody who creates and controls a permission blockchain can be a controller. Members of a consortium can be joint controllers. Node operators might be processors, and smart contract developers can be processors or controllers if they retain control. Mm-hmm. And there is one very important conclusion of it. If you create a consortium blockchain, create a legal entity that is determining permissions. Otherwise, everybody of the consortium might be considered to be a joint controller. The other thing I mentioned is third countries. So when you have third countries that do not, where there is no adequacy decision, you like the United, well, then the transfer to the third countries is restricted. And with the US, there have been adequacy decision, but they have been invalidated by the European Court of Justice, Schrems 1, Schrems 2, and now they're trying to do it again. And I'm not sure if it will succeed or will be just another round in the game. And you might only transfer with additional safeguards, which is quite limited. For example, you can have a cloud provider in the US, and if you only store encrypted data there, then it could work. But in most cases, you want to do more than that. And with explicit consent, or when it's required by the performance of a contract. And this could be the case, for example, when you do a hotel booking in the US, and you ask your travel agency here to do that. Of course, then they can transfer your data to the US, but these are limited cases. So if you have a blockchain, you might, public blockchain or even a permission blockchain, you might have nodes in the US. How do you deal with it? And the answer is simple. When it's a public blockchain, public permission or public permissionless blockchain, then the information is public anyway. And the European Court of Justice said already in 2003 that if you publish something, and it was about a social media post, if you publish something, it means that the third country rule does not apply. Why? Because otherwise publication would be quite limited and doesn't make any sense, because if it's public, it is public and it can be accessed from anywhere in the world. So they said the third country rule would be prohibitive for publication. Of course, you need to have a proper justification for publication. So if you have a proper justification for publication, then you can publish it and you don't have to bother with the third country rule. This might be an imbalance in the GDPR, of course, and this might be motivated because the third country rule is also motivated by protectionism. But I think it perfectly makes sense. But as with most things I say here, there's a caveat that there is no legal certainty about it. And I have not seen any court recently applying it to blockchain. And so there, to conclude, there are 5 ways to cope with GDPR. The first way is do not put personal data on a blockchain. As I said, it's easy to say, but it's not easy to do. Second, use privacy enhancing technology like hashes, like zero knowledge proofs, so that no personal data can be derived from the entries on the blockchain. Well, with one caveat is here as well, do not put encrypted data on a blockchain. It's not a good practice. It is for 2 reasons. Because you also, with encrypted data, you also need to have outside data to use it. It is large, and it creates a system that is like a system with a password that can never be changed. And according to computer security requirements, you should never have a system that is password protected where you cannot change the password. And this is part of GDPR as well. So don't put encrypted data on a blockchain and just say the password is somewhere else. Just use put the hash of the data on the blockchain and put the data outside. And then obtain a justification that is permanent. We talked about that. And of course, if the user puts the data on the public blockchain themselves, it's also fine, but be sure that it's really the user that wants to put it. And you're not just directing the user to do so, then this might not apply either. And then there is also the possibility to build specialized blockchains that can't forget. So if you have a specialized blockchain that forget, well, why use a blockchain anyway? Why don't you use a database? Well, if the possibility to forget is limited, for example, you can have a bookkeeping blockchain where everything is securely, immutably stored for 10 years and then deleted. Then it's fine because the immutability is still there, but it's limited. Or another example, you have transactions and you still want the transaction, the main transaction information there, but you want to delete part of the metadata of the transaction later on. Those things you could build, and they perfectly can make sense to reduce the amount of immutable information to that is well justified. So I'm happy to answer your question. Thank you for your attention.
Thank you very much, Jörn. Adam.
Thank you. Very interesting. So the layer one I'm working on, we have this ability where users can kind of delete data. But what happens actually is that data is marked for deletion, which is not the same. So that means that peers in the node may delete it effectively to reclaim some storage, for instance, but they don't have to. Actually, if you think about it, you cannot enforce it. And so I was wondering about the implications, the legal implications, when you have that kind of systems, because one of the points you said is maybe build systems where data can be forgotten, right? But most likely that's how you would implement it, as marking data for deletion, but not actually enforcing that it is deleted.
Well, of course, with the nodes, you cannot enforce them to delete it.
No.
If if you regard nodes as processors and you regard the deletion as something you have to do as a controller, of course, then you would have to enforce the deletion. But on the other hand, if it's public, you cannot enforce that everybody who has a copy of the data will delete it. You can and should, and this is required by law, send a request to everybody you know that has the data, and that's actually what you're doing.
Fantastic. Any other question, people? I have a very short one that relates to these roles of controllers, and it relates to blockchains that are permissionless but are proof of stake. Because when all they are born, in general, they have a lot of concentration of assets among very, very few people, and in general, they are heavily correlated with the creators of the platform. Does it change anything in the logic that you are using?
Well, in this case, you have a consortium blockchain.
You can assimilate to the consortium blockchain, this
Yes.
one. Okay.
And consortium blockchain can be public, of course. And in the consortium blockchain, you have control by the one who is determining who is part of the consortium.
Exactly.
So if you
Exactly.
if you have a majority in the consortium that do not want to do something required by law, you can move them out, you can move others in, and you have a different majority.
Mm-hmm. Fantastic. Thank you very much, Jörn, for your presentation. Thank you, people, for the discussion during this round. We are a few minutes late. We come in 20 minutes. Okay.